Hey guys, Steve Petrato here and Mr. James Haley from Horizon Hobby, and today we're going to talk about the 180 CFX. This is a new announcement from Blade and we're really excited about it, but we wanted to make sure that you knew the differences between the 180 CFX and the 130X and all the changes that we've made since the 130X. So let's jump into it. Alright James, well, tell me about the tail gears here.
As everyone knows, this is where kind of there was a sticky point on the 130X. We had some issues there. You know, they didn't end up really being ideally strong enough for the project. You know, after they got out in the hands of the consumers a lot, they had troubles in grass. We ended up having to glue them a lot to, you know, get them to stay in there. So that we just completely threw everything out the window on what we had, started from scratch, and just completely redesigned them. As you can see here, they are completely redesigned. They are much larger, much beefier. We also went to a different style, as you can see. You know, this is more of the bevel style, you know, kind of reverse. This is kind of a normal tail gear, 45 bevel, same torque tube design as a lot of the larger helicopters we've done.
Okay, awesome. That looks pretty strong. All right, so let's move on to the, let's go to the servos. So obviously there's a huge difference in the servos. I'll go ahead and pull those out here. We got the 130X servo here, which is a linear servo. And then we've got, looks like the 180 CFX servo, which is now a rotary servo.
Yeah, we've gone away from the linear servo. The linear servo has a purpose. You know, it's very lightweight. The torque on it is very strong because the worm gears lock. We went to a rotary servo on this due to kind of, you know, customer feedback. So
what are the main performance differences that we see? Kind of just, is it just the fact that they're stronger, more durable?
So obviously a rotary servo is enclosed. So guys that are flying in dusty conditions, you don't have to worry about dust getting in the wipers. It has a potentiometer in there, you know, a normal style. So you don't get any wear there from the sliders in comparison to a linear servo. Being enclosed is a big thing. Torque is one downside though. On a, you know, like on the worm gear, there's infinite torque there basically because the gears just jam.
Speed-wise,
Speed-wise, they're about the same. Okay. You do get a leverage arm now because you actually have an arm.
Right. So
you're getting a sweeping motion, whereas this had, you know, a linear up and down actuator. Okay. So that will actually come into how the servo layout is later.
Okay. Well, speaking of that, let's go to the actual servo geometry of the 180 CFX. So if you guys haven't seen the 180 CFX close, it's a carbon fiber frame, and in order for us to sit the servos in there, James had to do some design work on there, but we actually were able to integrate the optimized servo geometry that we've been so proud of that's on the 700 and the 300. So let's talk about that.
Yeah, so we shrunk down, basically it started with the 700X, and we put it into the 300 CFX, and this is the next generation of that. It's the optimized servo geometry. What this gets you is with a rotary servo, the arm is sweeping in and out, basically doing in and out motion on the swash plate, so you're losing some travel effect. Now that the servo arm is sweeping in the exact same plane and the same distance as the swash plate, you get a lot better servo geometry, and it makes the flybarrel system work a lot less. Okay. So you get a lot better performance and a lot less demand on the unit.
Okay. As far as replacement servos, are these non-standard or are they pretty standard?
As for the servos?
Yeah. Well, in order to mount servos into this.
Yes, for the servos, it's just a we believe we call it the sub micro servo. It uses just a M2 bolt to hold them in. Okay. The servo just pops in there. Also the hardware on it, they just use 1.5 millimeter Allens on all of the bolts, so makes it really easy to pop them in and out.
Yeah, these look obviously very strong for the task. I mean, these are just straight aluminum, solid aluminum here. These are not going to probably bend in any crashes or anything like that. Yeah. So awesome durability piece there. All right, what's next? You want to talk about the power system?
Yeah, let's go over to the power system.
Alrighty.
We've done a lot of evolutionary design work on the power system here. We've gone away from the in-runner motor, which was a point on the 130X. Got very hot. Didn't really fail a whole lot, but just the power-wise. You know, on an in-runner, as soon as you lose that RPM and it kind of gets down, not a lot of torque there at the lower RPMs on the mower. Now with the outrunner, we have a lot of torque now, which was what the 130 was really lacking. The RPMs are actually a little bit higher compared to the 130X as well. We're up at around the 5,000 RPM on the main rotor head, whereas the 130X was around 4,500. So with the larger blades and the higher RPM, it's got plenty of power now.
The KV on this motor?
It's 5,800 kV.
5,800 kV, okay. And this is a 3S capable motor.
Yep.
This was designed.
Yeah, so we're using 3S on this. Forgot to set this out. We're using a 3S 450 milliamp battery, 30C. It's got a JST connector on it. Nice, easy. We already sell the battery, so a lot of them out there.
Yeah.
And then the big thing here that we've done to change is we've gone to Castle Creations ESC. So that kind of harnesses all the power and makes it a lot easier.
Okay. All right, let's put the motor aside. That's a really nice looking motor. Let's go talk about the AS3X and how we've tuned that in the 180 CFX. I know there's been some, worked great in the 130, and now we're able to do a little bit more tuning and make it work even better for the CFX.
Yeah.
So what are the changes there?
Exactly. We kind of started from scratch on the flybarless system for this one. The AS3X and the 130X flew really well, but it didn't really have any Puro comp in there, and that was really necessary for a modern helicopter of today. We really wish we could have done it back then, but the way the code was kind of set up, it really limited us on being able to do that. So we started from scratch and completely just did a wish list of everything we wanted in the unit. And I'm really happy with where we ended up at. So
what is Puro compensation for those that don't know? What does it actually do while you're flying? How do you notice or how do you feel it in the air?
Yeah, so on the 130X, it was tail heavy, or no, it was nose heavy on the 130X. So the problem is when you pirouette, the disc, as you pirouette, always wants to nose down.
Okay, so it wants to tip forward towards the weight.
Yep, so in a hover, you really wouldn't notice it too much. If you did a really fast piro, it kind of doesn't really matter. But a slow piro definitely, has a problem then.
Okay.
The big thing there too is also if you're doing forward flight and you're pirouetting, you'll have a lot of pitching up, a lot of rocking. Okay. So now if you're in a hover and you sit there and crank the rudder over the model, the disc will stay perfectly flat and the model will pretty much almost stay stationary based on how much wind there is and that kind of thing.
Okay, so it makes 3D maneuvers, pirouetting maneuvers, anything really, just flying experience overall better because of the Puro compensation.
Yeah, a lot better. Also the way the feel is now, we kind of kept that same feel in the system, but allows us to track and do a lot more things inside the system, as we'll find out later.
Okay. All right, so that sounds like a really nice addition to the 180 CFX with the software there. All right, so you said Castle ESC, so this is huge. We're partnering with Castle Creations, and we're not just using our own ESC this time. This is a true Talon 15 Castle ESC, so that's really big news right there.
Yeah. We went to the Castle Creations Talon 15. Allows us to have a really powerful BEC, so we don't have to worry about a BEC on this model, as we are using 4 servos, one fairly big servo on the tail. So there's a lot of power draw there. Also, we're running full their software. So if a user wants to go in and change anything in there, they can completely do that.
So they can use the Castle Link software.
Yep, Castle Link software. You will need the adapter to the Ultra Micro lead.
Yep.
But the ends come pre-installed on it. It's ready to go. Big thanks to Castle for this. They really worked hard on it. And
yeah, that's awesome. Wow, very cool. That'll be a nice welcome change by everyone. Alrighty, so that's the Castle ESC. Now, real quick, you mentioned the tail servo. I know we didn't really touch on that with the servos before, but just looking at it, it is a big servo. So what do we do here in the servo?
Yeah, actually, we started out with the same kind of servo as the Cyclic, and just found out it wasn't really fast enough for the tail. So we went to the actual 76T and found out that was actually working really well. So we really couldn't complain, so we kind of modified the tailpiece here to fit in the larger servo. Nice thing is it's really overkill for the application and size and gears and everything, so you don't have to worry about stripping tail gears or anything. So the only difference we did is we shortened the lead on it and put the Ultra Micro lead on there for the AR6335 receiver.
Okay.
Other than that, it's the same servo, so everybody that has gear sets and that kind of thing out there already,
Yeah,
It's already out there.
this is a really fast servo, and we use it on the 450X, if I'm not mistaken, right?
Yeah.
So that's obviously a much smaller heli, and you're getting a 450 size tail servo, so the performance on the tail must be excellent.
Yeah, the tail performance on this model is really exceptional, and with the larger gears and not having to worry about anything like that, it really comes in handy.
Okay, awesome. All right, let's talk about let's see, the frame I think is next.
Yeah.
We'll talk about the frame. So this is a huge difference. No more plastic, right?
Yeah, no more plastic. We've gone away from the all-in-one plastic frame halves. We went to the carbon frame halves. One, it gives a huge rigidity increase, as well as also just the aesthetic look. It's just aesthetically more pleasing to.
Yeah, I mean this is not even mounted to the tail case, and you can't move this thing. It's rigid. These are 1mm frames.
Yep, 1mm frames.
Okay, so 1mm thickness on the carbon. You got your servo geometry laid out there. Motor looks like it mounts under here.
Yep.
So pretty easy to get to that. Wow, that's really nice. And these are probably very durable in a crash, if not unbreakable, just with the mass.
We
of this model.
have, give props to anybody that can break it because he did a good job there.
So you guys heard it. If you can break it, talk to James. No, it's gonna be a really that's awesome. Wow. So you got obviously the battery tray up here is plastic, but that's got our Blade logo on there. But that's where the battery goes.
Yep.
So
the one benefit too is we've gone to all metric hardware.
Oh, yep.
So there's only 3 Phillips head screws on the whole model that you actually have to use, other than the servo horn screws. 1 on the vertical fin and the 2 holding in the tail servo into the plastic. Other than that, everything is just uses a 1.5mm Allen wrench. So one tool to carry around, makes it a lot easier. You don't have to keep switching tools when you're fixing it. Makes it a lot nicer.
wow. Okay. Awesome. All right. So let's go to the rear of the helicopter now. We're going to talk about the whole drivetrain, the tail drive, and all the other pieces. So I've got some big components here. They look like they're from a different helicopter, but I assure you they're all from this heli, right?
Yeah. Yeah, we, as I said earlier, in the tail gears specifically, we've revamped the whole tail drive design. We started from scratch and really looked at how we could make that a lot better.
Well, so the 130, I mean, that was a carbon tube or square tube almost, and then that was the rod going through that. This is a full torque tube system, just like you would see on a large machine.
Yeah.
There's a ton of material here. This is a one-piece tail case?
Yeah, it's a one-piece tail case. It's enclosed on the rear, so you don't get any of the splitting, any of the walk in the tail shaft. We've gone to a 2.5mm size tail shaft, which is huge.
This thing right here, right?
Yeah. Also, the hub threads on now, so you can replace the hub if needed. You don't have to replace the tail shaft and the hub at one time. Also, on the tail case, before on the 130X, we had the collar next to the gear. We got rid of that. It's all one-piece gear, so there's actually 2 ways you can take the tail shaft out, or if you need to replace it. One, you can remove the bolt right here,
okay,
and then the whole assembly just slides right out, similar to the 130X, but you don't have, a lot less. You have to line up and that kind of thing. Or you can hold the gears and unspin the hub. It is reverse thread, so it locks as the more you fly it. But that allows you then to, if you just need to replace the slider, you don't have to remove the gears and all of that.
Okay. So tail maintenance is a breeze compared.
Yeah, tail maintenance is a lot easier. Also, we've gone to a little bit bigger grips, a little bit beefier, just to kind of strengthen up everything out back there.
Okay. Bearings in the grips, or how's this, bushings back here?
Nope. Dual ball bearing.
Dual ball bearing grips, okay.
Yep, similar to a larger helicopter. So
yeah.
The only thing we can't get in there is thrust bearings still, which is
right. That'll be tough.
Still dreaming, but one day we'll be able to get those in there, hopefully.
Alrighty, awesome. So that's a beautiful tail case. That looks like it's really strong. As far as durability on the tail gears, I've seen you fly this and hit the ground a few times, and I haven't seen you really.
Yeah, we haven't taken out any tail gears yet. Not saying that you can't, but what we are actually taking out is the torque tubes now. So there is, it's on to the next weaker link, but the torque tubes are, easy to repair. You remove the vertical fin, and the tail case just slides off. Pull the tail.
Now, is the torque tube? Does it have a bearing in it, or is it just a floating tube?
Yeah. So compared to the 130X, the 130X was the the torque rod. It was an aluminum rod. You could get whipping in there. You could get that kind of thing. So this is actually a larger style helicopter. It's a tube with plastic ends on it. They're pinned and they're glued. There's also a bearing inside, so it gets rid of any whipping on that rod. in that tube. So that allows for, you know, a lot better performance.
No vibration.
No vibration. No. Don't have to worry about splitting the carbon rod. It's pretty easy to tell if you bend the boom or, you know, anything like that in a crash. So visual maintenance is a lot better on this product as well.
And the tail boom is an aluminum tube, right?
Yep.
Okay, so pretty standard there, just like a larger heli, yeah. Alrighty, let's move up to the front tail case. So it looks obviously very big, same kind of setup as the rear. Are these the similar gears or obviously different set?
Same gears. So the torque tube gears are the same front to rear, and the
okay.
tail shaft gears is the same as the front to rear.
So you don't have to buy a lot of SKUs to get all your parts ready.
Yep. There's no A, B, C, D gear.
Okay.
You know, you have just those 2 gears. So if you buy a set of tail gears, I believe they come in a pack of 4. You know, you got quite a few.
Okay. And this tail case houses your servo, the tail servo, right? So everything's kind of connected there.
Yep. Yeah. No servo sitting out on the boom to move back and forth. It locks the servo into position. So if you replace the boom, it's the same position the next time.
Oh, that's nice. Yeah.
It's similar to a larger helicopter. Again, it's really a shrunk down larger helicopter design. Uses the same jack shaft gear. Also, the bottom gear is molded onto the shaft, so simply slide these apart, remove the hex posts in there, and the shaft drops out. You can replace the gears.
It's really like a big heli. That's just like a large heli. That's awesome. So obviously bearings supported on the top and bottom of the shaft here.
Yep, and 2 ball bearings in there on the torque tube gear as well with a spacer.
Awesome. Okay, so that's nice. Let's talk about the main gear and the main shaft here.
Yeah, so we've gone away from the carbon main shaft. We went to basically a solid metal shaft, which is increased strength.
So this is what, 4 millimeter?
Yeah, so it's the same diameter as the carbon shaft, but now you have the benefit of one, there's no splitting in a crash.
Right.
It's solid, so very little bending. Downside is there's a weight increase. Nice thing too is we were able to step the shaft, so you don't have to worry about a collar or anything like that to hold it. You simply slide it in, put the bolt through for the main gear, and you're done.
Okay.
And then if you want to remove the head, there's no removing, the upper gear, the main gear. The main gear is not going to slide up and down now anymore.
I see.
So you simply remove one bolt and you can pull the whole head out.
That's nice.
Makes it a lot nicer.
Wow. All right, well, is there anything else we want to chat about? Looks like we went through pretty much the whole helicopter here, and I hope that really makes it easy for you guys to understand all the serious changes that James put into this model and all the technology improvements that we have. Is there anything else that we didn't cover?
The one thing we haven't covered yet is the tuning and the radio. So what we've done here is on the 130X, you had to do the special bind mode, and that allowed you to get to the PID loop for all 3 axes. Kind of, not really user intuitive, just not as easy.
So it was the lights, and you had to move the lights up and down for gain.
And then you had faster flashing, slower flashing. Not really an easy way to tell what was really going on there. We still haven't kind of finalized exactly what these values are going to do, but we kind of wanted to give you an insight into what's available. So I'll power this one up here real quick and give you an idea of what's available on the model.
So all the tuning is pretty much from your radio, right?
Yeah, so if you have a more advanced radio, DX7S, anything with telemetry built in, available in the radio, DX6, the new one, DX9, you can get this new gyro gain menu. If you have a DX6i, an old style radio, you can still actually adjust the tail gain via channel 5, so default 9 is 75%. You can raise or lower that, and that'll scale the PIDs together. Sure. So if you get a little bit higher tail gain, you want a little higher, you can do that, a little lower. But if you want some of this more advanced features, you gotta have a little bit more higher.
So this is getting into the real detailed flybarless adjustments.
And out of the box, you won't have to adjust any of this, but it gives us the ability to kind of have a little bit more adjustability to the user. And we'll probably do a video later, kind of going into more detail once the values are finalized. But what you can do now is it's more of a kind of a forward programming here. So if you go basically sticks into the corner and hold the button.
There's the bind button. So hold sticks in the corner, hold the bind button.
Yep,
down.
and this is assigned to, I believe, aux 2.
Okay.
So now if you go into the telemetry menu, we have values. And what these are is cyclic PID. So to scroll through them, you would use aileron, so now we're on integrator, derivative gain. So if you want to reset it, You can just hold the rudder over there.
So these are just, you're able to really tune it to how you want it to fly.
Yep.
It's not just how we set it up, which we feel is really, really awesome, but if you really want to get in there and get detailed, I mean, we don't need to go into all the detailed menus here, but it looks like, I mean, with everything on this radio, you can really absolutely update.
Yeah, the one nice thing now is, you know, the PIDs, we really don't expect you to ever have to adjust. It's there if you want to, but you don't really need to. The one nice thing is, the fourth menu is we have kind of a cyclic acceleration. So if you want it snappier off center, you can increase and decrease that, and that really helps, you know, tune it for a pilot's liking. There's a couple other features, and then to simply get out of it, you just push the button, and it'll go back. So it's really nice there.
Well, we'll definitely do a couple of videos. I know that people are going to ask a lot of questions about what do the PIDs do, and I'm sure you can walk them through that. So we'll definitely have that video for you guys after this. Well, awesome, James. This is a kind of a legendary, you know, product for this market. There's really nothing else out there on the market like this. I know I'm excited about it. I'm sure you're even more excited about it. So
yeah, excited to be able to get out and fly it in public. You know, it's been a long time in the works. You know, thanks to God for all the customers, you know, clamoring for a V2, and hopefully we didn't disappoint with this one.
Yeah, I would say that we have definitely not disappointed. This looks awesome. Well, good job, James. Thanks for sitting down with me and talking, and hope you guys enjoy the 180 CFX. And make sure to check out, if you have any more questions, check out our Facebook page. That's going to be facebook.com/BladeHelis, or go to our website, bladehelis.com, and check out the product page. Thanks for watching, guys.
Thank you.